Up to now you have understood three looping statements available in C language. One is while loop, second one is do while loop, the third one the for statement. The for statement is a very interesting statement and it will be useful for remaining part of the programs that to be executed. So, for loop is used for a repetitive execution of a statement or a group of statement. As you observed in the last hour, we have understood the initial expression, the final expression and the update expression. All these statements which are there inside to be repeated. Example. So, for I is equal to 1, I less than or equal to 10, I plus plus. Observe in this statement, I value is initialized to 1 until the condition I less than or equal to 10, you are going to increment the value of I plus plus. First it checks the condition, if the condition is true, if this condition is true, the control goes inside and execute this statement. After executing this statement, the control goes back and increment the value of I, and then it checks whether still I is less than or equal to 10, that condition is true, control goes inside the loop and execute this statement. This statement will be executed until this condition is satisfied. This is how we can, through a graph, you can observe this for structure. The keyword is for, left parenthesis, this is the first step, step 1, initialization of the variable I equal to 1, there is a semicolon, condition, after this condition is true, immediately jumps to the statement 1, execute if a single statement or a multiple statements that will be get executed here, and after execution, after the last statement, control goes back. And observe this is where the updation of that variable is taken place. Remember, in for loop, you are not supposed to update the value of variable I inside the loop. You can only use the I variable for any one of your statement, but you should not change. The changing of this variable, any variable that you are going to use for index purpose, that should be updated in this portion only. After the increment is over, the control goes back and once again goes to the step I condition checking. The true, step 2 continues. This is how the for loop executes in the programming statement. So, that is why we say the first one is initialization, semicolon, condition, semicolon, iteration. There is no semicolon here, remember this point. Usually you will do this mistake by putting a semicolon, then the body of the loop will not be executed. So, this is the continuation statement. So, if you have more than one statement to be executed, put in begin and end. So, this is an entry controlled for statement which will be useful for repetition or a looping statement. So, the initial expression is usually an assignment expression, update expression is an increment or a decrement expression, depend upon the problem domain, we are going to use increment or decrement process. The final expression is the relational expression, results in the value true or false. If it is true, control goes inside, false, control goes outside the for loop. An example, for up to m to n, you want to print the values from m to n. For I is equal to m, that is the initial value, until I value less than or equal to n, that condition is true, you are going to increment the value of I and printing the value of this I variable. From m to n, the values will be get printed on the output. This is how you can use for loop in your programming statement. One example of the previous one is demonstrated. For x equal to 0.1, that is the initial value. Whether x is less than 1.0, if it is true, control goes inside, print the value of x and x square. Observe this, x is 0.1 and its square is 0.01. After printing this, there is a gap. Because of this, /t, that is the tab operator, helps in giving a space between these two numbers. So, these two variables that will be get printed on the output. Here this is also percentage f and this is percentage f, because you are using floating variable. So, these two x and x squares you are going to repeat until x less than or equal to 1.0. After the execution, after the first time, x value is incremented by 0.2. 0.1 now becomes, and add 0.2, it becomes 0.3. 0.3 and its square 0.09 will be printed. Next 0.5, next 0.7, next 0.9 and its square is 0.81 is printed. In the next iteration 0.9, when you add 0.2 to it, it becomes 1.1. This condition will not satisfy, the control goes out of the program. This is how a for loop can be used. I think you have demonstrated to find out the factorial of a given number using the for loop statement. This is the same program you can also write using do while loop statement and while statement and as well as for loop. You can use forward, that is increment or decrement of your variable, that can be done. Here we are shown with a decrement variable. You know factorial of a number n factorial. It is defined as n into n minus 1, n minus 2 into n minus 3 up to 1 or up to 2 if you do it, because when you multiply with the last one it is same. For that reason, observe this, I is initialized to n down to 2, fact is equal to fact into I, print fact variable. So, reading the first value n and initialize one variable, say factorial equal to 1, initializing the variable I from n down to 2, repeat the statement fact is equal to fact into I, the old value of fact is get multiplied with I and the new value of fact is get obtained. After the completion of the loop, your result will be available in the fact variable, you can print it. This logic can be shown through a program. So, here these are all the variable int n is the variable that you are using, I fact, initializing fact variable to 1. Enter a positive number. You remember this, factorial of negative number is not defined. You should enter only positive number. If user enters negative number, you can use one logic here. If n less than 0, you can say printf not possible to find out factorial, and you can go out of the program using any of the taking the control outside the program. Else you can start reading the value, that is whatever the value n, the read, for I is equal to n, initializing I is equal to n, I less than or equal to 2, I minus minus, this is the decrement operator. First fact is get multiplied with n, for example 4 is given, 4 is get multiplied with the 1, 4, next time it becomes 3 I, because you are decrementing by 1, 4 into 3, 3 into 2, by that time this condition fails, the control goes out and prints the factorial, and this is how you will get the values of positive number 3, the result will be given as 6. This is how we understood how to find out a factorial of a given number using for statement. So, this is the for statement you are using for many purpose. You have to understand so many requirements in the for loop. For loop is a very flexible construct. It can also be used for decrementing the counter instead of incrementing. I think in the previous, to find out the factorial, you use decrement instead of incrementing. So, observe for n count equal to 100 semicolon, n count greater than 0, n count minus minus. At each time the variable n count is decremented by 1 until it becomes 0. This process is repeating. This is an example for decrementing. Similarly, instead of decrementing always by 1, you can also decrement your value or increment by some other number also. Just only the change is you change your n count plus equal to 3. It is similar to n count is equal to n count plus 3. Like that you can change the counter value by as per your requirement. The initial value can be omitted in the test variable which has been initialized before. For example, if before this for statement you initialize n count equal to 1, then there is no necessity of reinitializing once again here. Just you put a semicolon, it is implied whatever the initialization is done previous to this statement, it will be taken, and then your condition will be as similar to this, the process continues. So this is another way of using the for loop. So you can also observe the for statement can be followed by a null or a empty statement, so that the task is done in the for loop itself. For example, you want to repeat 20,000 times. Here you observe for count is equal to 0, count less than 20,000, count plus plus, you put a semicolon. Here or here if you put this statement, the same statement will execute 20,000 times. Assuming that to execute this one time it requires 1 millisecond, then totally this statement provides a pause or a delay of 20,000 millisecond. Up to 20,000 millisecond the same statement will be executed, and then the control will be jumped to the next statement. This is how you can introduce a delay in your program by making the semicolon at the end. It will not give error, it makes the statement executed as per your instructions. So this is another way the for statements are used. These are all the same program that what you understood in the last hour to sum a series 0 plus 1 plus 2 plus up to 20. How this program can be written using for statement. Let us, so the program like this 1 plus 2 plus 3 up to n. N is the number which user gives. You ask for the user to enter the value of n by making use of the scanf statement. You read that number, scanf %d ampersand n. N is the number that you are reading. So here you want to sum to this all this number to a variable, say sum. Main int begin. Now you are using one variable sum, another variable n. Int sum initialized to 0 and the variable n. These are the two variables you are using up to now. Now user will give this the value of n. Up to n you have to sum your series. So here you can use your for loop. For I am using one variable I initialized to 1 because it starts from 1. I declare this variable I here as integer variable, put a semicolon, that is initialization part is over. Now you have to put a condition until this variable reaches n, I less than or equal to n. Put a semicolon, this is the condition. At each time it is incrementing by 1. So you increment I equal to I plus 1, or short form you can also write I plus plus. Put a close bracket. Inside the loop you have only one statement, there is no necessity of begin and end. If you have more than one statement, use begin and end to be get executed inside your for loop. So here the value of new value of sum equal to whatever the value of sum is there initially, it is initialized to 0, add I to it. Then the control goes back, I is get incremented, next value is taken, it is added. This process repeat until this. So now you are having your result in the variable sum. You can print that printf sum equal to percentage, because your integer variable %d, close this, put a comma and put that variable sum. Get ch is the statement used until you are going to see your result. Get ch helps you to see the result on the computer screen. Put a semicolon. The last statement of your program is return 0. If you use this, you will not get any warning. Close of this program. The remaining things are similar, that is include stdio.h, that is you are using scanf statement and printf statement. Since you are using getch function, you have to include one more statement, that is conio.h. Conio.h, console input output header file. So when you run this program in Turbo C environment, you can also see the output which are present for your previous program also be seen. in order to avoid this, you can introduce one statement here after your declaration, that is CLR SCR. This is a short function which is available in the C language to clear your output screen. If any of the output is present in your output screen, that will be washed out and new program output will be seen. This function, if you want to use, corresponding prototype or header file should be available in your program. This prototype is present in conio.h, conio.h, hence it will not give any error and start executing. So this is how you can develop your program using for statement. So if you have, assuming that your sum series starts from 2, increment by 4, 6, like that. If you observe this, the initialization only have to change, I equal to 2, that is the first step. Second step, I less than or equal to n, anywhere the user has given up to n, here it is incremented by 2 plus equal to 2. At each time it is incremented by 2. You can also observe an interesting statement sometime. One is negative, first one is negative, next one positive, negative. At each time positive, negative, like it is changing. You don't know what is going to happen at plus or minus n. How to develop this logic? So anywhere at the initially it will be 2. At each time, if you observe that whatever the value you get, that should be made negative. Next time it should become positive, for which I will introduce one variable s or sign or any variable initialized to 1, positive number. Inside the loop, I will change the value of s equal to s into minus 1. What happens? First time the value of, when you are going to multiply your I with s, it will be positive because the first number is 2, 2 is get multiplied with 1, 2. Next time the variable s I initialize to 1, 1 is get multiplied with minus 1, it becomes minus 1. So when the control goes back, when you observe in the second statement, when I become 4, the value of s is minus 1, 4 into minus 1 becomes minus 4, you got your value. In the next iteration, minus 1, you know the value of s is minus 1, minus 1 is get multiplied with minus 1, resulting positive number. So becomes 1 and the control goes back. When you are getting the value of is 6, 6 is multiplied with 1, 6. That is how it is changed from plus to minus like that. So this is how you can introduce a simple one statement to change the sign from positive to negative, negative to positive by multiplying itself. This will be useful when you want to compute a sign series. I think in the coming classes you are going to observe to calculate the sign of x. Sign of x is defined in mathematics as x divided by 1 factorial minus x to the power of 3 by 3 factorial plus x to the power of 5 by 5 factorial. It is an infinite series. If you observe first time it will be negative, positive, negative, positive, like that it will continue. So in order to do this operation, you can use this simple logic of maintaining it. So this will be taught in the next hours. So the same observation you can make if you want, if the series is 1 by 2, 1 by 4, 1 by 6, 1 by n, like that if your series is there, small manipulation you have to do it here. It is 1 divided by the corresponding I variable multiplied with s. But here you are using all these variables of integer type, then the obtained result will not be correct. So you have to convert your variable into float. The n variable, that you can take it as integer only, int n. So remaining all other variable, if you take it as I variable is also integer, you take this. So remaining things follows. So here 1, the I variable is also integer, this is also integer, the result will be integer value. To avoid this, you are going to introduce 1.0 and compute. So then we will be getting your result sum in floating value, change this control string to percentage f. These are all the small minor changes that should be done whenever the corresponding problem changes from integer domain to floating point domain. So, this is regarding the usage of for loop in the programming statement. Let us move on to nesting of for loops, just similar to if else condition. If you want to nest the for loops, one for loop inside another for loop, that is called nesting. How it works? It is an interesting statement in programming. If you observe one example which is shown here in the example, for I equal to 1, I less than or equal to 2, I plus plus. There is no semicolon here, remember this. Begin for, you are putting one more for loop inside another for loop. Here you are initializing another variable j which is equal to 1 semicolon j less than or equal to 3 semicolon j plus plus. How this for statement works? Initially for I is equal to 1, j varies from 1 to 3 and execute this statement. After execution 3 times, the control goes back once again to the first for statement. As per this instruction, I incremented to 2, and since 2 is less than, as per this condition it is true, less than or equal to true is true, control goes once again, j is reinitialized to 1 once again to 1, and this statement c is into ij execute 3 times because you have put a condition like that j less than or equal to 3. So, this is the mean. For each value of I equal to 1, j varies from 1 to 3. When I becomes 2, once again j varies from 1 to 3. So, this is reinitialized and execute 3 times. This is how the nesting of a loop or one inside another for loop that can be used. So, this can be used to generate a multiplication table, that is you are familiar with the multiplication table. So, 1 into 1 equal to 1, 1 into 2 equal to 2, up to 1 into 10, 10. This statement you want to generate for 1s, for 2, for 3, 4, like that you want to generate a table. So, in order to generate this table, you can use the nesting of the for loop. For I equal to 1, I less than or equal to 4, because you are generating up to 4 table, I variable is used to generate the 4th up to 4th table. I is incremented 1 1 because after the first table you are using for the second number, third number and the fourth number. J varies from 1 to 10 because at each time 1 into 1 to 1 into 10 you want to j. So, this variable is I and this variable is j. So, j is initialized to 1, generate printf percentage d, this is multiplication symbol, percentage d equal to percentage d, I j I star j. I value is initially 1, j value is 1, 1 into 1, 1. This is how the first statement, first output you will get. So, after this if you observe slash t, that is why a gap is maintained, and then control goes back and j becomes 2. 2 is less than 10, hence once again it prints 1 into 2 equal to 2, that is 1, 2, 2. This is how you get. So, this process repeats until j value is 10. Whenever the j value becomes greater than 10, control goes outside this loop, printf slash n, the control, after this statement, the new statement start executing from new line. That is slash n helps in carriage return, the new line character. The control goes back and j I is now become 2 because you are incrementing I by plus plus, that is I by 1, I becomes 2, and when I is 2, j varies from 1 to 10 once again. That is why 2 into 1, 2, 2 into 2, 4, like that it will continue until 2 into 10 is equal to 20 is repeated. Then after this control printf slash n goes outside this loop and make I value become 3, third number table you will get it. Similarly, fourth number table you will get it. So, this process is repeated until I less than or equal to 4. You want up to 10 numbers, replace this by 10, up from 1 to 10 table that you can generate on the output to get the result. So get ch helps you to, until you are going to press a key, this output will be seen on the computer screen. So corresponding header file for get ch is conio.h, because you are using printf, you are using stdio.h, these two header files. So this is how you can generate a multiplication table using nesting of for loop, one for loop inside another for loop. You can also introduce one more for loop inside. It executes as per the rules of nesting for one with another. So let us move on to understand this, how to generate this structure. Write a program to print the below structure using star. So I want the inside in the output 1 star, 2 star, then 3 stars, then 4 stars. So this is the output I want. A simple logic. Observe this. First time when you are doing in only 1 star to be printed. Next 2 times star. So you can start like this. For only printing logic it is. For let us assume for I is equal to 1, because there are 4 lines you have to print. For I less than or equal to 1, in the 4th line you require 4 star to be printed. I less than or equal to 4, each time increment the value by plus plus. Begin. Now you have to print the value of star only. So let us introduce one more for loop for j is equal to 1. Here j is equal to 1 means in the first time it should be 1 only. For that reason you are going to put a condition j less than or equal to I, not the number. When I is 1, only one time. When I become 2, 2 times the star will be printed. J plus plus. Printf, that is the star you are printing, you just type the star, whatever the number, whatever the string you want to print on the output, print and put a slash t, close this, star will be printed. This statement will execute one time in the first, when I is 1. When I becomes 2, the control goes back. When I becomes 2, 2 times to be printed. So after the first time printing, your next line should be printed from the new line. Hence you have to introduce one statement, that is printf slash n. This helps in making, after the first line is printed, the next statement start printing from the new line character. So this is how you can take the control of printing the star. Instead of this, you want 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. This is the output you want to print. Instead of star, you just replace here the value of j. In order to print j, you know that j is a variable of type integer, %d, put a comma, j variable you print. So at each time when initially the j value will be 1, because j you are initialized to 1, 1 will be printed. After the first iteration, the control goes back, I becomes plus plus, I becomes 2, j starts from 1 to 2. That's why first j will be printed as 1, slash t take the control gap, and then 2 is printed. Next 1, 2, 3, 1, 2, 3, 4, like that it will print. A small exercise you can do, how you can complete to introduce next 1, 2, 3, 1, 2, 1. So this structure, if you want to print, add the remaining part of the routine by making use of the same for loop and get this result in your output. So this is an interesting structures that can be printed by making use of the nesting of the for loop in the programming. So another interesting structure, instead of this, the reverse order, 4 star first, then 2, 3, this structure reversed. Observe in this statement, there are 4 stars in the first line, next 3, next 2, 1. So in order to generate this, instead of using forward that is incremented, now we will make use of the decrement minus minus I. I is initialized to 4, I greater than or equal to 1, minus minus I. Begin for j is equal to 1, j less than or equal to I, the same condition, plus plus j, and inside the loop printf star slash t. First time, because we here less than or equal to I, the I value is 4, hence 4 star will be printed. After the 4 star, the control goes back, I becomes 3 and 3 star will be printed because j starts from 1 to 3, and this process will repeat 3 times, next 2 times, next 1 time. That is how you can get 4 star in the first line. Because of printf slash n, control goes back to this statement, generate this 3, 2, 1. This is how you can generate this by making use of decrement operator here, minus minus I support. You can generate a structure of this kind. So you can combine one more for loop to generate in reverse order to look in a different structure on the output. So this is the help of the nested for loop in the programming. So up to now you understood the usage of for loop and its structure to generate some interesting output on this program. Sometime you require to continue your process instead of doing in the loop. You want to go back once again to the condition and start executing. So there is one interesting keyword which is available in C, that is called continue keyword. Continue keyword forces the next iteration to take place immediately, skipping any instruction that may be follow it. After the continue statement, if there are any instructions are there that will not be done, the control goes back to the condition statement of any of these repetition statements such as for statement or do while and while statement, and check for the condition. If it is true, control goes inside. So this continue statement can only be used inside a loop for do while and not inside this switch statement. Remember this point. And also when it is get executed, it transfer the control to the condition, the expression part of a while loop or do while loop, and increment the expression in the for loop and make your condition checked. Increment the expression and make your condition checked. If it is true, once again goes otherwise. So this is an advantage, useful in some time you want to skip some of the statement for some condition to be enforced in your program. Unlike the break statement, continue does not force the termination of a loop, but it merely transfer the control. So only control will be transferred to the place of condition part and start executing. Let us understand with a small example how this continue statement that can be used. I want output like this: 1, 2, 3, 4, 5 should be skipped, and then it should start 6, 7, 8, 9 up to 10. So here 5 should not be printed in my output. How this can be generated? So similar to our previous program, you observe for inum equal to 1, inum is a variable you initialized as an integer variable. If inum less than or equal to 10, because you want to generate up to 10, you are putting a condition inum less than or equal to 10. At each time after each number is incremented by 1, you are incrementing inum plus plus. This condition is clear. Next, whenever this number becomes 5, you should not print on the output. For that reason, begin if inum double equal, observe this, this is a conditional statement, that is relational operator, that is equal to sign, inum double equal, that is equal to 5, continue. Otherwise, if this condition is not true, it will just print the num. That's why when I number is 1, it will be printed percentage d, 1 is printed. When inum become 2, it prints 2, 3, 4. When it becomes 5, continue, control goes back, increment the value of inum by to 6 and checks whether 6 is less than or equal to 10. If it is true, goes inside the loop. This will not execute because I number is now 6. It prints the value 6. This is how you can take the help of continue statement in your program to skip some part of the code. This part of the code is skipped when this I number is 5. So control goes to increment in for loop and checks the condition. So this is the example to demonstrate how continuous statement that can be used in your programming. So, let us understand go to statement. So, this is another interesting control statement to take the control to some other statement of your program is go to, G-O-T-O, go to statement. As the name itself said, the control will jump to the statement whatever you are going to specify in the label. The go to statement is one of the C unconditional jump. Up to now you observed, if the condition is true, control goes inside the loop, otherwise it will goes outside the loop, whereas a go to statement takes unconditional jump or branching in the statement. When program execution encounters a go to statement, execution immediately jumps to the branch where you are going to specify. Though it can be unconditional because after this statement you are not put any condition, simply say go to label. Label is the statement number or a statement location where the control should be jumped. Branching does not depend on any condition as such. So, remember some points in go to. A go to statement and its target label must be located in the same function. It should not be outside the function, because you are writing only the main as a one function. We will write go to within the main function only. If you are writing small functions as written, then the go to label should not be present in any other function. We will understand later. And one more statement you should remember is, however, using go to statement is strongly not recommended in the programming. Try to avoid this. Replace this, if you really want to go to statement to be used, replace by use any of other branching statement using while statement, do while statement, like that. When program execution branches when a go to statement, no record is kept from where the execution is coming from. So, this is the drawback of maintaining the go to control in your programming. Anyway, just to understand this statement, let us see. I want the output like this: 10, 11, 12, 13, 14, 15 is missing. Observe this, 15 is missing here, 16, 17, 18, 19. So, you have to generate the number from 10 to 19. 15 should not be present here. How to generate this number? As you observe, this is similar to your previous program. Your int a equal to 10, you are initialized because you are starting from 10. Do statement, observe this part, loop colon, you forget about this part, I will come back. Do begin, inside the begin, do and while put a condition. If a double equal to 15, a is equal to a plus 1, it is get incremented by 1. Otherwise, after this, go to loop, control will be directly jump to this statement and start executing from this statement. Initially, when a is equal to 10, since a is not equal to 15, it simply print the value of a is 10. A plus plus becomes 11. 11 is less than 20. Control goes back to the do statement and checks whether it is 15. No, 11 will be printed, 12 will be printed, 13 will be printed, 14. Whenever a becomes 15, this condition says a is 15, hence a is now incremented to plus 1, that becomes 16. Go to loop, this is the statement, go to loop. Loop is called label. You can use any label that you are comfortable. Here they used a label called loop. You can say go to next. You type next in the statement where the control should start from this. Loop semicolon, control goes to this. Here there is one syntax, that is colon. After the label you should specify the colon. So, the control goes to this loop and start executing the next one. Now, the value is 16, it is not equal to 15, hence it prints the 16 and 17, 18, 19 until a less than 20. For that reason, you will be getting up to 19. When a becomes 20, this condition fails and control goes to return 0. This is the usage of go to statement in your program. This loop or a label that can be above or below of your statements. Simply the control goes from this position to the position or the statement wherever that label is given. That is why this statement is called unconditional. There is no condition to say from where it should be started and to be get executed. This is the help of go to statement in programming. Many times you will try to avoid the go to statement in the programming. Let us understand the usage of for loop to calculate whether the given number is prime or not. Prime number is a number, you are all familiar that number is divisible by itself and as well as by 1. It will not be divisible by any other number, that is called prime number. Example for the prime number are 13 is a prime number, 7 is a prime number. Like that you can list out any other numbers that you are familiar as a prime number. Now user will give a number. Now you have to say whether the given number is prime or not. How to check whether 13 is a prime or not? First what we will do, anywhere all the numbers are divisible by 1, I will not check from 1, I will check from 2. First 13 is divided by 2, whether you will get a remainder 0, remainder, remember this. If the remainder is 0, then it is implied that number is divisible by this number. When you divide it by 2, the remainder will not be 0, remainder will not be 0. Next, the same number I will take, I will divide it by after 2, I will divide it by 3. If you get remainder 0, process is over, the given number is not a prime. But whereas if the remainder is not a 0, then I will go once again dividing it by the next 13 by 4. Then also I will not get the remainder 0, then I will move to 5. Then I will move to 6. 6 2s are 12. Then I will check 13 divided by 7. 7 2s are 14. Then there is no necessity of checking from here onwards. So whatever the number is given up to off, if you are going to check whether it is remainder is 0 or not, if the remainder is not 0, it is implied that the number is prime number. So if we take 12, when you divide it by 2, automatically the remainder is 0. So when the remainder is 0, you can simply announce that 12 is not a prime number. Whereas when you take 13, it will start from 2, 3, 4 up to half of its number. That is, if the given number is n, up to n by 2 if you are going to check, if the remainder is not 0, it is implied that is a prime number. So this is the logic for checking for a prime number. Let us develop this logic through programming and make your programming clear. First, as usual, you will start your program from include stdio.h, include stdio.h, conio.h. This is the programming. You are familiar now why these header files are required in the programming. Next, your program entry through the main begin. If you want to return some value, you will give the return value, that is int, or if you do not want anything, then we use void start begin. Now you are checking for a number, ask for the user to enter a number, let it be integer, that is the n. First send a message to the user to enter this number by through the printf statement, enter a number, enter a number. User has to enter a number. How to take the data? You are familiar with one of the statement that is called scanf. Scanf %d ampersand n. Because you are using integer variable, in the corresponding memory location the data will be get stored. Now you got your number. Now you have to check whether that number is prime or not. In the output you should say n, the given number is prime or it is not a prime. Any one of the message that should be printed. So let us start checking using for loop. Initialize for I is equal to 2, I is equal to 2, I less than or equal to I less than or equal to whatever the condition you are going to put n by 2, that is up to half. If you are going to check, it is enough. For that reason, at each time increment the value by 1. So begin, calculate the remainder r. R you are introducing, r is another variable, and you are introduce one more variable I, you take this. This is how, whenever you start using the variable, the corresponding variable, try to declare its data type. R is equal to, how to take the remainder? You are having one interesting operator, that is the mod operator. Take n mod I. When you do this, you will be getting its remainder. Check if r equal to double equal to 0. If r equal to 0, if the remainder is 0, then it is implied given number is not a prime. Printf number percentage d is not a prime. Not a prime. Put a quote, put a comma, corresponding n is the variable you printed. So number, that whatever you typed, say 12, number 12 is not a prime. That is how you will get an output if remainder becomes 0. If the remainder is not 0, then you have to repeat your process for your checking with the next number. If this is true, then get ch. There is an interesting statement available in the programming. To go out of the program, anywhere is already, you have checked your number, you can use one function that is called exit 0. This is one built-in function available to take the control outside the program and close this. If it is not true, once again, if r is, remainder is not equal to 0, control goes to this position and goes back, and your value is incremented to 1. Now I become 3, checks that number divided by 2. If remainder 0, it does it. Otherwise, this process will repeat. Just like 13, if you give, checks for 2, 3, 4, up to 6, 7, it will check. Whenever this condition fails, control goes off. It is implied that remainder you have not got 0. Then in that situation, you printf given number, that is percentage d, given number percentage d is prime. Close this, put a comma, which is that number, that is n. Get ch, end of your program. This is begin and end. So in this logic, you used if condition inside your for loop to check for a condition. If this is true, it does this part. If this is not true, that is false, control goes to this statement and goes back. As per the for statement, it increments, check for the condition. If it is true, goes inside the loop. So this process repeats. If you given any number as 13, say example, it will check for divide by 2, divide by 3, divide by 4, divide by 5, 6, 7 and up to half. After this, whenever the half of that number is reached, it is implied the given number is not a prime. Control goes and print. So this is the logic that can be used. Here you used if logic, for statement and everything embedded to form a statement. So this is the help of for statement that can be used whenever you want a repetition that can be used. In this program, it is demonstrated the same thing that you can observe and get the result in your output screen. So in the next hour, let us understand some of the important other operators which are essential for us to do some more statement that can be introduced in the program to make our programming simple and very effective. ಆಗಿರಲಿ.